So today we're going to have a look at isosceles triangles and circles, and by the end of today we're going to be able to describe what a chord and perpendicular bisector is, describe how to create isosceles triangles and circles, and then apply these facts and problems again by creating right angle triangles. So a chord is a line joining 2 points on the circumference. So I'm just going to take point A, say here, let's get a pen, point A here, and point B here, and the chord is basically just a line that joins A and B on the circumference. Now, also, if you've got the diameter is also a special type of chord that just passes through the centre. So I'm just going to take that away. Now, if 2 points in AB are joined by chord AB, then we can form an isosceles triangle. And the way we do that is by starting in the centre, and the radii, it forms a triangle. And obviously, isosceles triangle, that comes from the fact that we're using the two radii, so they are equal there. So that's R, and that's R as well. And again, we can apply this into problems with angles, Pythagoras, and trigonometry. So, example 1, we're going to find the size of the shaded angle. Now, because this is an isosceles triangle, this side and this side are both the same. Remember your properties of isosceles triangles. That also means that this angle here must be 30 degrees. So, shaded angle, well, we've got the shaded angle is 180, angles in a triangle, take away 30, take away 30, well, that's 180, take away 60, so we've got 120 degrees. So the shaded angle is 120 degrees. Now, to use Pythagoras and trigonometry, we've got another wee kind of bullet point we need to take down, that a perpendicular bisector is a line which cuts another line in half at right angles, obviously. Right angles, perpendicular, those link up there, and bisect means to cut in half. So, I've got point A here, I've got point B, and what I'm going to do is I'm going to draw in a perpendicular bisector from the radius, and I'm going to call the centre O and this part C, and it creates right angles. Now, obviously, we can use Pythagoras and trig in circles, so these, just remember, are still the radius, and that they're equal. So let's have a look at a couple of examples. So example 2, find the length of the line OC. So we've got a right angle triangle. Now the first thing I would suggest you do is you actually draw out a separate wee triangle, so a wee right angle triangle there. Now we know the hypotenuse is 5 centimetres, and this is a right angle using the property mentioned before. Now, because this is an isosceles triangle, what we know is that the base is cut in half. So if the whole base is 8, then this wee bit and this wee bit must both be 4. So we are going to find OC, so let's give that a name. We'll call it x. So x squared, now small side for Pythagoras, it's 5 squared, take away 4 squared. So we've got 25, take away 16, which is just 9. So square root of 9, and it's just 3. So 3 centimetres. The perpendicular bisector OC is just 3 centimetres long. Okay, next example we're going to have a look at is example 3, and we're going to find the length of the chord this time. So we're told the length of the perpendicular bisector. Again, what I'm going to do is I'm going to draw out the triangle. So I know that this is 5 centimetres. I know this is 13 centimetres. Again, I'm using the short side of Pythagoras, so I'm just going to put an x in there. And we've got x squared equals 13 squared, take away 5 squared, sorry. Just fix that. So take away 5 squared. X squared, well, 169, take away 25, and that comes out at 144. And we should hopefully know that the square root of 144 is just 12 centimetres. Now, we're not finished there, because what we've said is that this is 12 centimetres, but because it's an isosceles triangle, what we can say is that this is also 12 centimetres. So, in order to complete the solution, you must then say that AB is actually 24 centimeters. Okay, AB is 24 centimeters. So the last thing we're going to have a look at today is an exam style question. So we're going to apply this into an exam style question. So the diagram below shows a circular cross section of a milk tank. The radius of a circle, centre 0, is 1.2 meters. Now the width of the surface of the milk tank is represented by ml, and it's 1.8. So this bit here is 1.8 meters. So let's just draw that in. And we're asked to calculate the depth of milk in the tank. So the depth is highlighted on there. So first thing we've got to do is create right angle triangles. Now, similar to the other diagrams, I'm going to just draw in the radius on each side, and then our perpendicular bisector. And as you can see, that diagram's quite small. So what I'm going to do is I'm actually going to just draw out a bigger triangle, and we can put the information on that. So we do have a right angle there. Now, if the whole ML is 1.8, that means that this bit must be 0.9, half of that. And we're told in the question that the radius is 1.2. So again, Pythagoras, and we're working with some decimals this time. So let's call this x. So we're going to have x squared equals 1.2 squared take away 0.9 squared. Now that is 1.44 take away 0.81, and that leaves us with x squared being 0.63. Now take the square root as normal with Pythagoras, and we get that to one decimal place the square root comes out at 0.8. So what I've figured out is that this bit here is 0.8, and that is the bit, let me just change colour, that is the bit I'm colouring in yellow that we've worked out to be 0.8. Now we're asked to work out the depth of milk in the whole tank. So what do we know about this bit here? Well, it's coming out from the centre to the circumference, so that is actually the radius, and we know the radius is 1.2. So to find the depth, we worked out that the x was 0.8 plus the radius, which is 1.2, so the depth is actually just 2 meters. So a couple of learning points from that question. The first thing you should do, draw in the right angle triangles, and I would highly suggest that you draw a separate triangle at the side just so you don't overload your diagram with information. Then work out what form of Pythagoras you're using, and then remember that we've only worked out our small x in a triangle. We then need to add on the radius to get the total depth of the milk.